Hello everyone. I'm Paul Drabble, Global Marketing Director at Delta Q Technologies, member of the Zappi Group of companies. I'd like to extend a warm welcome to everyone tuning in today for this next session, Enhancing Autonomous Mobile Robot Performance with Lithium-Ion Battery Technology. It's my pleasure to introduce our two speakers for today's session, which looks at the advantages of lithium-ion over traditional lead-acid batteries, including safety, efficacy, efficiency, and sustainability. Robin Schneider is the Director of Marketing at Cubes Technology, and John Barilleaux is a Senior Sales Manager at Hubtex. So before we begin, if you have any questions during this session, please add them to the Q&A tab at the top right of your webinar screen, and note that all your questions will be sent privately. I'll disappear now behind the scenes, but I'll be back at the end to facilitate a brief Q&A at the end, and we'll answer audience questions in the order they are received. With that said, I'd like to hand off to Robin and John. The session is now yours.
Wonderful. Thank you for the introduction, Paul. So just kind of get started. So Robin and I decided that we wanted to collaborate on this because one of the issues that we see in the industry is efficiency and the utilization of AGVs and autonomous mobile robots, and how lithium batteries can increase the efficiencies and the productivities of these machines. Over the years, we've worked together on other projects, and we found some areas that are maybe some issues that need to be highlighted. So we thought this was a great opportunity to do that. Paul, go ahead and advance the slide, please. So what we kind of were thinking is we wanted to begin with the end in mind, right? So in some of our experiences working together, what we have found is that in a lot of cases, companies will design AGVs. Customers will spec an AGV that they want. They'll work with a company to develop a product, and then they get all the way through the design cycle and they realize they need a battery. And then they say, okay, well, I have this much space for a battery, but now how do I fill that space? What kind of capacity can I get in that space? I need this much. We did all these studies, and I need this much capacity in order to make the throughput that I'm looking for. And now you go out to find a battery to fit, and it doesn't work. You know, the batteries in a AGV is not a commodity. It doesn't really work that way. The battery inside the AGV is actually truly the heart and soul. Nothing works without a battery, and the battery has to communicate with the AGV AMR in order for the machine to operate and do the job that it needs to do. So that's kind of why we wanted to say, okay, well, let's take at the very beginning, let's take a look at why this is important. So go ahead and advance the slide again. So a little bit about Hubtex. So my name is John Barilleaux. I'm a senior sales manager for Hubtex. We are primarily a side loader manufacturer based out of Germany. Go ahead again. We have several verticals that we're in, but our primary verticals are aerospace, custom equipment, and then building materials. Say steel service centers and lumber mills tend to be our bread and butter. So these are some examples of that. The picture on the left there is a picture from the old Boeing 787 production line. I don't know if you can kind of see along the left-hand edge there looks like a big blue elevator type machine. That's one of ours. It's a mobile freight elevator. The side loader there in the middle is what we would consider a custom machine, and that's actually a cheese storage facility. So believe it or not, those are all cheese wheels in there, and this machine goes in and pulls out the racks in and out of the cold storage for the cheese. And then, of course, everybody can probably imagine what the machine on the right there is. That's just a standard side loader, a DQ, three-wheeled machine in a lumber facility. So just kind of an example of some of our verticals that we're in. Go ahead and advance again, Paul. So Hubtex has been around since 1981. Believe it or not, back in the 80s, Germany, Fulda, Germany was actually the center of the textile industry. So Hub in German means lift, and Tex is for the textiles industry. So that's really where Hubtex cut its teeth, was developing these machines for textiles. And of course, all that shifted into overseas and primarily to China. So they had to reinvent themselves. And so that's really where they got into the side loader industry and kind of our standard product line. Go ahead again. So for us, really we do have some very standard products, but because what we do is there's a lot of integration and with the rack systems and the customer's individual needs. Every machine that we build is tailored to the customer's need. So we're very much a full service, hand in hand solution provider. We've got many years of experience, great German engineering. Um, it's quite incredible the capabilities and staff that we have, not only in Germany but also in the United States. And we can do not only do we build new equipment in Germany, but we can also recondition and reservice equipment in the United States. We have that's where I'm currently at right now, is our facility in Ohio, where we can do ground up restoration as well. Go ahead and go forward again. So just very recently, we stopped manufacturing IC, internal combustion side loaders. So we no longer do gas or propane diesel powered side loaders. Everything is 100% electric. And that's really where kind of the key again is coming back to where we are today is why. And it comes down to efficiency. Having a 100% electric side loader with, in a lot of cases, we try to do electric steering as opposed to hydrostatic steering because it's super efficient. We can get our average consumptions down into, the 3 kilowatt per hour range, or even lower in some cases, depending upon the use. So it really drives efficiency home. And of course, with, lithium batteries and the charge curve and discharge curve that they have, that only really helps to exemplify that efficiencies. So, and then of course, because of electricity and electric trucks, we're a lot safer. Everything has got electric brakes. So it makes it so that we can be more prepared. We can do collision avoidance, object avoidance. We can do personnel avoidance. Really just drives home that safety, quality, efficiency type standard that we're looking for. Go ahead again, Paul. And go ahead one more. So automation is kind of a buzzword right now. Everybody's talking about automation. Everybody's talking about AI. But in our world, what does automation really mean? What is automation? And I think this is a really cool little slide that just sort of kind of highlights what automation and the basics of what a side loader, forklift would have to be able to do in order to be autonomous. And so, you'd have to have mapping. You've got to map out your world. You've got to bring your real world into the digital world and tell the AGV how it's supposed to navigate and maneuver in that space. You've got to avoid obstacles. In a lot of cases, you're going to have multiple AGVs running, whether it be one-way streets or maybe byway routes, and you have to know what machines are on what routes. And then, as a machine goes by and notices that there might be a blocked path, it should report that back to either the server, what we call the mothership, and the mothership needs to let all the other AGVs know that, hey, there's a blocked path. Now you have to route around it. It needs to be smart. It needs to be intelligent to know that, hey, this. In order for you to complete a task, you have to do something that's not the standard route. You have to detect the load. You have to detect if the load is protruding. Everything that we take for granted as a human and you do with your eyes automatically, now you have to figure out how a machine can do that as well. So you have to know if maybe the pallet's broken. Well, how are you going to detect that? How are you going to know that pallet's broken? How are you going to know what the weight of the load is? Is it the same weight that you're expecting? Is it overloaded? Is there something odd there? And then positioning is obviously important. If you're trying to position, whether you're positioning in a rack or making an AGV for like an assembly line, and you've got multiple pieces coming together, you need to get everything to line up, where normally with a human, you could just basically just by maybe tribal knowledge, you just kind of know where it needs to go, or maybe you have a pin in the floor and you just know where to drop it. An AGV doesn't necessarily have that. So you've got to figure out, again, how to get the digital world into the real world, whether that be a sensor that's looking for a monument in the floor, or, in some cases we've looked up at the ceiling and looked, for something there as well. So it just really comes down to how are you going to make sure that you're in the right spot at the right time. And then you've got lifts. If you're going in and out of a rack, we do AGVs that go in and out of rack systems. So height is important. And then you've got mass deflection at height, all these things that we just take for granted as a human operator that can just go in and drive a machine. Now you've got to figure out how to actually teach a robot to do that. Go ahead and go to the next slide. So, and then of course, not only do you have to teach the robot, but you also have to think about all the other encompassing things around that, right? And these are all things that use energy. So you've got to have an app, which means you have to have software, which means you have to have an IPC that's going to run that software on the AGV and also in the server. You've got to have battery management, which is ultimately important. That goes down, kind of comes back to the heart and soul of the machine. How does the machine interact with that battery? How does the battery communicate with the machine? And so that it knows when things may or may not be working the way they're supposed to be working. How does that get to fleet control? When is it going to go on and off charger? Those sort of things. You've got to have service. Green Cubes has a great remote maintenance product that we've used. It's phenomenal for giving us information on battery status and maybe even alerting when things aren't working the way they should, so you can schedule maintenance as opposed to being reactive to maintenance. But you've got to know how to do the service, the transfer, the know-how to the customer. You've got startup production, not only for the AGV production, but you've got production as in an AGV that's in a production environment. We need a layout, aisle widths, walls, intersections, how really everything kind of lays out in that environment, how to put it all together. Training and everything we do AGVs and we turn them over to the customer. So it's a very heavy, intense training regiment because at the end of the day, we want the customer to own it. If they want to change routes or they want to change how the AGV responds or reacts in their environment, we want them to be able to do that. So you've got then you've got your interfaces with the warehouse management. Sometimes you need the AGV to go through a door. So now the AGV has to communicate with like a PLC in order to activate the door, things like that. So there's a lot of interfaces, a lot of communications. But charging batteries, keep kind of running back to that. That's all key. And the charging concept and how are you going to charge? Are you going to use an inductive charger? Are you going to use a foot? If you use a foot, you're kind of limited to 50 volts is max for that. So anything above 50 volts, you kind of need to go inductive. You've got to have that battery management. You've got to have the protocols in place so that the battery and the AGV are talking to each other, which ultimately is a huge point. In the past, I've worked with several other lithium battery manufacturers, and we've had to write our own code in order to make it so that works. Where Green Cubes, not to keep touting them only, but I love them. They actually, their BMS system, I can go in and with drop-down menus, select things that I want my AGV to see, hear, understand. So it makes it very seamless and easy to be able to integrate. As an integrator, that's super important. You need those tools to be able to put A and B together. So go ahead and go to the next one. So for our AGVs, in most cases, we use an object-based navigation, and kind of wanted to point that out. Object-based navigation works extremely well. Every time an AGV runs a route, it remaps that environment, sends that environment up to the mothership. The mothership sews those maps together. It's an ever-evolving space, but it's great for, as I said earlier, like any sort of bilateral routes. It'll tell you if things are blocked. It tells you where a machine is. Tells you if somebody's moved something. Maybe it can't see a target because somebody's put something in front of it, or maybe can't see a rack or a column. So it's very, very useful. Go ahead and go to the next one. So this is kind of an example of what LiDAR feature-based navigation looks like. In this situation, we have a glass truck that we've done where we're using a scanner sort of mounted on a pole at the top, and it's looking all above all those frames and looking at the beams or the columns for the building. So it's navigating off of that at probably about a plus or minus 20 millimeter position tolerance. So pretty accurate in a fairly large space. But, again, going back to efficiency, the key here is it's electric steered. So as opposed to if you were doing hydrostatic, the pump's constantly running and the wheels are making adjustments over and over, which is really consuming energy. In these situations, we're using electric steering so that we can really be efficient. The wheels can make minor adjustments without having to run a pump. And then go to the next one. And this is another example of sort of that steering coupled with different drive functionalities, safety fields, and different camera technology to not only come in to a load, recognize the area is clear, make the rotation around with collision avoidance. And then once the forks are lined up, using a center camera with technology or knowledge to identify the load. Maybe there's a QR code. Maybe we're just looking for fork pockets and spacing. Just really depends on what that load is and how to really coordinate to that load and then safely pick it up. And then again, of course, electric steering is the key. And this is, an omnidirectional vehicle, so it can go drive sideways, turn around its own center in like a carousel mode, and then drive forward towards the fork side in order to pick it up. And then go ahead and go to the next one. And this really kind of comes down to, again, the charging. In this scenario, you can see the AGV is sort of up against a docking station, and we're using a foot. So it's really a charger foot. It's a 48-volt AGV. This is the picture is actually in our experience center in Germany, so you can see the large TV behind it. This is one of the ones that kind of comes in and out of our center when we bring customers to Germany to show them what we produce and the machines that we make. But this is a really great example, kind of showing again that charging is ultimately important, and opportunity charging for an AGV is really the key, because the AGV is always on and it's either discharging or charging. It's never really in an idle state because there's so much electronics that are running. So where a regular forklift maybe will drop down to less than an amp of current, because the only thing that really will be left on could be some sort of warehouse management monitoring system, where an AGV has got all the sensors are always running, the IPC is always running, it's always communicating with the server. So in some cases, we're drawing 5-6 amps of current just sitting idle. And that doesn't seem like a lot, but over time, 5 amp hours is a lot in a 24-hour space of sitting idle. So what's really key is that the battery knows that it's never truly going idle and can calculate the state of charge accurately and can report that information back to the AGV, also along with state of charge, cell balancing, any of that information. And then the picture on the bottom right, I'm sure most people in this space have probably seen something like that before, but that's what a charging foot would look like. So you've got copper contacts that as an AGV will get towards the docking station, it'll park itself in the right spot, it'll verify that it is in the correct spot, then the charger foot will be actuated, so it'll lower down, or in most cases it lowers down, but we have done some that are on the side where I'll push over to the side, it'll make contact with the copper, and then we'll get a signal, very low current, low voltage signal that's been made, and then via CAN bus, wireless CAN bus, we'll start the charge. And then that way the battery controls the charger and gets exactly the charge that it needs. And again, that drives efficiency. You're only putting the energy in that you're expecting, that you want to get out. You're putting you can charge for 15 seconds, you can charge for 30 minutes, you can charge for an hour without any degradation to the battery. And the AGV can always constantly be running, because if you're going to do an AGV, you're not a single shift application, you're running multiple shifts, and the AGV should never stop. So these are all really important things to note, that the charging is very important, and that that's where lithium comes in, is it allows you to do that high current opportunity charging. Go to the next one. So for a couple of case studies, we've done some AGV type systems. For us here in the United States, we started with Boeing. And we thought that was they were really our launch customer. In the United States, the first AGV system we did was in 2015. And it was for layup mandrels and trim fixtures. And then since then, we've done some rack systems. We're actually delivering it. That's what before the meeting started, we were talking about trips to Germany, and I was there a couple weeks ago to buy off an AGV that we're doing for another aerospace manufacturer. So aerospace is sort of where we started in the AGV space. We've done a lot. We did this rack system, AGV that you see here in the picture. This is just sort of in our test center that we did. In fact, this AGV, if you guys were at FabTech in 2016, the AGV was actually there at that show. But it's been around. We've used it for a few things, but it's really, what's unique about it is it's able to get in and out of a rack system. It's able to coordinate with cantilever racking. So unlike pallet racking, cantilever racking, you're going to have multiple pickup points relative to the load, not just the position of the rack itself. So it's got to know not only the load that it's going to grab and the position of that load, but it's got to know where the center of that is in the racking system and then coordinate itself correctly. So it was a really unique machine at the time. It's been in use for a while. Pretty good machine. Go ahead and go to the next one. And this is another AGV that we did for Boeing. This is, again, the one I kind of mentioned for the stringers, layup tool fixtures. It's 30 feet long by about 4 feet wide. And it picks up tools that can be up to 45 feet long and 6 feet wide, and drives them in and around a factory, in and out of narrow aisles. It's omnidirectional, which was a very unique thing at the time to try to make an AGV that was omnidirectional. And then the steering programs that we had to put in order to get in and out of the aisleways was quite unique. In some cases, we had to get the nose sort of down into the aisle and then swing the back around and then back up a little bit and then turn some more and then drive forward. It was sort of like maybe a little bit of an Austin Powers-like type thing where you're trying to get into this aisle and you're making these little moves. But they're very efficient. They don't have very large batteries in them. They're actually 48 volt, 200 amp hour batteries. But because of the way, even though they run 3 shifts, 24 hours a day, everywhere they go, if they stop, they drop a charge foot. So they're constantly discharging and charging all day, every day. So they literally will never sit idle. They're always either on charge or on discharge. And because of that, we've really been able to keep the batteries in a very healthy state. These were brought in 2018. I just was out there a few weeks ago and we took some measurements on the battery to kind of see where they were. And I'm not really exactly quite certain how many charge cycles the batteries have been through, but I can say that the cells are still above 80% of what their original capacities were. And considering they've been in constant use, that's quite good. I mean, we didn't expect that. They're an older cell technology, and they really were only they were only expected to do about 1,000 cycles, and I'm sure we're way well over that, probably in the 3,500 cycle range. So I would say that's a big success for that battery. And I think go ahead and go one more. And then this is one that we did. This is for copper coils. This is Demos. It's our sister company manufactured this one. So Hubtex is, not only are we a manufacturer in Germany, but we own several other manufacturers, Demos being one of them. They make AGVs as well. And this is one that we work together on for this coil manufacturer. And it's pretty basic, but it kind of shows the production level machinery. These coils came off the banding machine and then needed to correlate over to a rack system. So it's just really picking from several different machines for the banding and then taking it over to a transfer station where something else picks it up and puts it in a rack. But it was a long driving distance, and pretty much straight lines. So the machine, once it gets driving, there's really not a lot of draw other than just kind of the friction on the floor. and then goes into the drop zone, drops it off, and then comes back and picks up the next one. But it was this one also was a lead acid, which meant it had to have a charging room, took up a lot of space. They had to figure out, the acid abatement. They had to figure out how they were going to deal with the fumes. And so it really had unfortunately, I don't know that this was in the battery technology the best use case for these. I think the customer wasn't confident with the lithium, and so they went with the lead acid changing station. And I think, over time, I think that maybe would have been a mistake, and I think they would agree to that. But it was still kind of early on in the lithium game, so they were a little more risk adverse than others, which is kind of interesting. You bring in an AGV and yet you're still risk adverse. And then go ahead and go to the next one. So that pretty much concludes my portion. Like I said, I just really wanted to drive home that the battery really truly is the center of the heart of the machine. And really, it's very important to kind of think about that at the very beginning, whether you're buying and looking at, purchasing AGVs, or you're a manufacturer of AGVs, but don't just make a machine and look for a battery. Try to start with the beginning and end in mind, so you kind of know what those requirements are moving forward. So I will go ahead and pass it over to Robin. She's the marketing director for Green Cubes, and a super genius.
John, you flatter me. We're also quite good friends, if you can't tell. So thanks, John. That was a great introduction. I'm going to talk a little bit about Green Cubes and who we are and what we do. And I'll talk a little bit about the general benefits of lithium, some of the charging algorithms and how that plays into what John was talking about in terms of design for AGVs. It's really critical. Also talk a little bit about product technology. And then finally, I'm going to talk about quality best practices and what to look for in a lithium-ion battery supplier, so that you are equipped to make an educated decision once you start down this path. So next slide, please, Paul. And before I continue, actually, I'd like to encourage the audience to go ahead and put questions into the chat tab as we move forward, so that we can have a healthy Q&A here at the end. So go ahead and do that as those questions occur to you. So Green Cubes is a lithium-ion battery manufacturer. We design and manufacture rechargeable lithium-ion battery solutions that are safe and accessible and easy to use. As John mentioned, there are drop-down menus for selections and things like that. Our solutions ease the migration away from lead acid and internal combustion engines and other older technologies. Our vision is to design platforms to help accelerate the adoption of clean energy mediums. And we have a very happy team here in Kokomo, Indiana. This is the interior of our headquarters, where we do our motive battery manufacturing. And if you'll go to the next slide, please, Paul. That is one of several locations that we have. So that's our headquarters in the United States, where we do our motive battery manufacturing. We also have engineering staff in Switzerland. We have software engineers located in India. We also have supply chain experts in Taiwan and other engineers there. And then manufacturing in Malaysia as well. We were established in 1986, so nearly 40 years in this business. We have 300 employees and well over 100 power designs in general. But not this past September, but the September before, we celebrated the 10-year anniversary of being in the motive power industry with our flagship product line, the Lithium Safe Flex batteries. So that was a huge milestone for us that represents about well over 10,000 batteries in the field and about 300 megawatt hours of power. So we have a lot of experience in this space. It is not novel at this point, and I think that's why it's time to start looking at quality best practices and things like that, because the technology is not really that novel anymore. So next slide, please. Okay, so a little bit about me. I am the marketing director at Green Cubes. I am also a scientist by training. So I have a PhD in materials science. I studied with John Goodenough, who won the Nobel Prize for inventing the lithium-ion battery in 2019. So I'm going to geek out for a minute here to start with a seemingly very technical slide. But it's pretty accessible, I think, pretty easy to understand. So what you have here in this graph is a graph of energy densities. So how much capacity does the battery have? How much energy in a given space do you have? And then the power density. How much current or power is it able to deliver within that space? So is it high power or does it store a lot of energy? And you can see this is a logarithmic scale. So like an earthquake, the one that's in the upper right is significantly more than everything that's in the lower left. And you can see that the internal combustion engine really actually outperforms most other energy storage technologies. And you can see things like a capacitor, for example, can deliver similar amount of power, but it can't store enough energy. And then on the other hand, in the upper left, you have something like a fuel cell battery or a lithium air battery that can deliver a lot of capacity or can store a lot of energy, but doesn't have any power density much at all. And you can see in kind of the middle upper quadrant or section, the lithium-ion battery. So there's a big, sort of large bubble there because there's a number of different chemistries that fall into that category. But a lithium-ion battery basically gets as close as you can to the internal combustion engine. And that's why lithium-ion batteries have become sort of the default option for power in basically every space, from a small cell phone or an earbud to all the way to an electric vehicle or an electric truck or bus. So next slide, thank you, please. So the benefits of lithium, besides being able to deliver both power and capacity, we are able to deliver superior performance that translates into fast lifting, fast travel speeds at all levels of discharge with a very flat discharge curve. In addition, a single battery can have a service life of more than 3,000 cycles. So typical warranties are in the 5-year space, even with like a 24/7 type operation. You can fast charge in less than 2 hours, in some technologies as low as about an hour. And that translates to the ability to truly opportunity charge. And that enables something like an AGV or an AMR to charge opportunistically at any opportunity that gets for, say, 10 minutes at a time. And you can really recognize that like full 24/7 operation. In addition, lithium-ion batteries are safe and sustainable. They have a low carbon footprint. They don't have any hazardous fumes or acid spills like a lead acid battery might risk. You eliminate things like battery watering and changes and shift changes and something like a material handling equipment. So next slide, please. Okay. So the core of a lithium-ion battery is the battery cell. And at the core of the battery, you have the cell pack. And then you have battery safety features surrounding that electronically, and then advanced features that surround that electronically. So the battery management system or the electronics that you would need to design for an AMR to be specific to that usage scenario would have features like core safety features and monitoring voltage, current, and temperature, and having a safety disconnect. And then it would have more advanced features like state of charge, state of health, that there's heating or cooling necessary if it's used in a cold temperature storage facility or refrigerated storage facility. You might look at that. It needs to communicate with the AGV. You have safety integration levels and cell balancing, and all of that needs to then communicate in an integrated, seamless way to the AGV. So that's the kind of electronics around the cell. That's the core building block of the battery. Next slide. I want to dive into cell balancing a little bit because it's really, really important. So the battery management system performs this function called cell balancing. And what this does is basically make sure that the battery or the cells are at an equal level of charge. So in a cell pack, you might have 5, 6 cells or something like that. And it's generally required with any time you have more than 4 cells in a battery pack. And so what happens is that the cells charge, if they start at a different level, then they charge up, the top one hits the top, and then they discharge, the bottom one hits the bottom. And over time, the degree of disconnect between them grows and grows and grows. So the usable capacity in the pack becomes smaller and smaller, regardless of how much the net energy contained in that cell pack is. So even if you just bleed off some of the energy from the top, if you keep those cells closer together, you'll have more usable energy overall. So that's important in terms of maintaining capacity over time. It's also important in terms of safety because you increase the risk of having an over discharge, an overcharge or an under discharge, which creates a safety concern. So if you're ever looking at a cell supplier, or a battery pack manufacturer, this is something that you want to discuss with them. What is the approach that they use for this? Because while you could have a very advanced version of this, that would also, though, increase some complexity and things like that. So cell balancing is just an important thing to kind of understand at a core level and talk to your battery pack supplier about. Next slide, please. Okay, so like John said, the charging algorithm for lithium ion is one of the things that makes it so advantageous for an application like an AGV that's going to be operating 24/7. So I want to take a moment to compare a lithium ion battery charging versus a lead acid charging. So we have here on the left just a random lead acid battery charging profile, and then a generic lithium ion battery charging profile. And you can see they're basically the same. So first you do a constant charge current, and then you hold at that voltage level, and then you let the current kind of taper off and fill up the last bit of the battery. So these charge profiles look basically the same. Oh, sorry, we skipped ahead one slide. So they look basically the same, but the difference is that those the scales of these two graphs are completely different. So for a lead acid battery, you can only fast charge to about 80% with lead acid, and with lithium ion, you can charge to like 95%, and then you can taper off from there. So what that translates to is about an 8-hour charge time for a lead acid battery, and less than 2 hours for a lithium ion battery. And that makes it so that you can do that opportunity charging that's so important. Next slide. So the recommended charging algorithms for lead acid basically are, you charge at a C/5 rate. So that's a 5-hour charge time to 80% capacity. And then you have to have an 8-hour cool down period and equalize the battery on a weekly basis. That translates to basically 1 full charge and 1 full discharge every day for a lead acid battery if you use them in their recommended charging algorithm. A lot of people do a fast charge or about a C/2 or a 2-hour time frame, but that almost always will shorten or violate the manufacturer warranty. And over time, it will degrade the battery and you won't get the full warranted lifetime of the battery. So in the event that a lead acid battery manufacturer is communicating to you that you can fast charge it, always ask for the details of how that's going to affect the cycle life of that battery. With lithium ion, on the other hand, regardless of the state of charge of the battery, it'll efficiently accept power, and it'll increase its state of charge. So it can be immediately charged and discharged. It has no need to cool because it's very, very efficient. So it doesn't heat up as you're charging it generally. You can accept nearly a full charge in a little over an hour, so a 1C rate. And with that, you can get 2,000 to 4,000 cycles with a, down to about 80% of the original capacity, like John had mentioned for that application earlier. Next slide. Specific to green cubes, we have something called a multi-voltage battery that can actually increase or decrease that charge time by about 50%. So this is just a technology I want to make everybody aware of. It sounds a little bit confusing, but basically what you do is you keep constant power on the discharge and the charge, and you charge at double the voltage and half the current, and then you discharge at double the current and half the voltage. So it's constant power, but what that means is that you can, for example, charge a full 48 volt battery at 96 volts and then half the charge time. It also will decrease the size of the cables required for charging if you're using cables, which you probably wouldn't for an AGV, but it's worth pointing out anyway. And that will reduce the charge time even further, so that you have a lead acid charge time that's like, say 8 hours, you'd have about a 2 hour or hour and 45 minutes for a regular lithium ion battery, and then maybe 45 minutes or so for this multi-voltage type of technology. Next slide, please. Okay, so with the current economics and things like that, return on investment is extremely important for a decision about what type of technology you're going to use. And so I would like to take a moment to look at the difference between a lithium ion battery in terms of operating expenditures and capital expenditures versus a lead acid battery. So in general, lithium ion batteries can increase the productivity and lower the total cost of operation by about 30%. They also are about 98% efficient versus 80% efficient with a lead acid battery. And that translates to a reduction in electrical or utility costs by about 20%. It increases the safety conditions for your associates, so that can be associated with health insurance costs, and all of that stuff can be like rolled into a lower operating expenditure. The same thing with improving your environmental conditions on the site. Because you can be just opportunity charging the battery, you can have 100% asset utilization. And you can also lower the maintenance costs because the lithium ion batteries have a very flat discharge curve. Versus a lead acid battery that has a very sloped discharge curve, which means that it has a much more consistent power distribution over its time, and that reduces the overall truck maintenance. You also, with a lithium ion battery, you don't need as much floor space because you wouldn't have to do any battery swapping. It decreases the need for battery handling rooms, ventilation accommodations, eye wash stations, and all of that safety gear as well. So next slide. So we want to look at just some example data. We have this calculator on the Green Cubes website. So if you go to greencubes.com, you can find this calculator. You can plug in your situation where you have lead acid, lithium ion, what the number of devices you're using, and it'll spit out a result of what your capital expenditures look like and what the operating expenditures look like over a 5-year period. And you can see how much the cumulative cost difference is. So for this example, we just plugged in some kind of generic numbers, but if you had, say, 80 trucks over 5 years in this example, you actually look at a $4.2 million operating expenditure reduction in that time frame. The next slide. Okay, so now we're going to talk about quality best practices and how to evaluate a lithium-ion supplier. The first one is, I'm not going to go into this in detail, but the most important thing, like John said, is that you want to evaluate what your actual power consumption needs are, and that involves the commissioning process. You have to understand how the asset is actually utilized and understand how much power is required, when is it going to charge, for what a period of time, and all of that, so that you have a battery that's like really well integrated into your individual application. Next. So quality starts with safety. So at Green Cubes, we really view quality and safety as an integral part of our company culture. And it starts with, at the top, with management buy-in. We start every meeting with a safety and quality moment. And employees are empowered to, bring up anything that they've experienced that may be a safety or quality concern. And they're also empowered to stop the line if there is an issue that they see. And so we align all of our teams, service, technology, engineering, to be in this kind of mode of thinking that quality and safety are our number one jobs. Next slide. You also want to look at the product integration testing. So again, this is for an AMR and AGV where you might be designing a battery specific around that use case. You want to do vehicle level function tests or Hertz cycle tests to ensure compatibility and functionality. You want to make sure that the CAN communication integration is seamless. You want to do climate testing for cold weather operation and things like that. Make sure that you don't have any unforeseen issues that come up because of the environment that you're using the battery in. The next slide. We also want to drive quality and reliability through structured failure analysis, including root cause analysis or understanding product failures at their core so we can implement corrective action and prevent recurrence, containment or immediate action to address identified issues, corrective actions, so immediately implementing solutions to ensure quality control, and then we always want to have a thorough engineering analysis of any returns that we get. Next slide. And when you're looking at manufacturing, you want to look for things like computer automated test equipment, which will ensure precision and accuracy, things like in-house automated laser welding, and then using computer controlled technology for torquing equipment and things like that. You want to minimize the hand contact of the manufacturing in the battery. Next slide. And so this is the final slide, but really it's very important. And I think John and I are demonstrating here that having cohesive communication between the AMR and AGV manufacturer and their development team and the battery manufacturer and their development team is really key to making sure that you have a successful implementation. And you really want to tie together all of the communication between service, operation, engineering, and even sales, and have things like weekly reviews and monitoring and feedback loops. And you have an assigned account manager to make sure that you have a really smooth customer interaction between the end user, the end customer, the AGV or AMR manufacturer, and then the battery manufacturer as well. So cohesive communication is really key to having a successful implementation. Next slide. All right. That's all I had. Thank you. Those are our emails there. If you have any questions that come to you after the presentation's over, and I'll turn it back over to Paul for the Q&A.
All right. Thank you, Robin. Thank you, John. I apologize, Robin. My laptop seemed to be doing weird things and advancing slides without me even touching it. So some gremlins did appear during your presentation. I realize that must be a little disruptive when they keep bouncing around, but
Oh, that's no problem.
not sure what's really
Hardly
going on. So anyway, here we are. So thank you, terrific presentations from both of you. We've got actually quite a few questions here that have popped up. So I'll jump straight to the first one, and either of you can jump on. So what is the favored lithium chemistry for AMRs that run 3 shifts, 24/7?
Well, I'll go ahead and handle that one. So in our experience, LFP, lithium iron phosphate, is our go-to chemistry because of the warehouses and the environments that we run in. A lot of times we're around very high dollar equipment, machinery, flammable materials. And I don't want to say that one chemistry is necessarily safer than the other. I know that like an intrinsic level, LFP is safer because it's not as volatile. It doesn't have the bonded oxygen molecule. It is at a very core level safer. And in some cases where we have had an event where a battery did, maybe there was a short, an accident, something happened. Really the only thing anybody ever noticed is the battery smelled funny, as opposed to, something more volatile, more dangerous. But I think, as technology has gotten a lot better, especially in the lithium realm, from what we've seen, the LFP, even though it is a little heavier, it's a little larger. But again, if you build the AMR around knowing what battery you're going to put in there, the LFP is in my opinion, far superior chemistry.
Okay, so the next question is, which battery chemistries are preferred for an AGV versus an AMR, and why?
Well, I think some of that might be a little bit of conflict in terms as well. So, and I'm not an expert on these terms. I find them, they seem to be changing constantly or ever evolving. Originally when we started doing autonomous mobile robots, we called them AGVs. Anything that drove around on its own was an AGV. And then, of course, now with cars and other, equipment that's traveling and driving autonomously, it seems like the AGVs for warehouse equipment, manufacturing equipment is sort of pushed more into the nomenclature of an AMR. I'm a little older in my terminology, so probably maybe it's not correct. But in really that you've got in, like, let's say a forklift that drives around, as it's moving throughout the warehouse, it's an AGV because it's autonomously guiding itself around and driving. And then once it reaches a rack system, then it sort of changes into an AMR because now it's got to coordinate with the world in which it's in, pick something up safely, visualize, and do all the sort of the robotic type portion of that. So, but again, I think it just comes down to the chemistry and the efficiencies of that chemistry, the how many cycles it can, you can charge it and discharge it, the lack of heat, and really you get 98% of the energy into the battery, or back, you put 98% of the energy you put into the battery, you get back out. So your capital expenditure is reduced by 20%, and you've got a long life, situation where the batteries are going to last and you don't have to do the routine maintenance that you would with a lead acid.
Okay, next question. Do your lithium batteries support Unified Diagnostic Services, UDS?
That is not a term I'm familiar with. Do you know that, John?
Yeah, that's more of an automotive thing. So
Okay.
I think for Green Cubes, their BMSs use can open, which is very, it's the UDS is a communication protocol, but it's also like a unified manufacturers. And I'm not 100% on this, so please don't quote me on any of this, but it's more or less a way of like having an error and a message that coordinates between the manufacturers what that error is. And it's in the, all the motor controllers and all those devices that are in the, in an automobile. So the BMS in the Green Cubes battery is can open, and that most likely, if there was, maybe a device that could translate that to the code that you would need, it would most likely work, because I believe even in that realm, because vehicles still use can open as well. I think you could figure out a way to make the two together. But as far as I know, directly, no, there isn't really yet. I know Green Cubes is working with other manufacturers to develop a standard, but as of right now in the industry, there really isn't a standard of error messages and CAN protocols and all that. It's still somewhat in the early phases of development.
Okay, I think this might be a question for Robin, from Steve. Assumes that you ship and service to Canada, but maybe
We do.
recycling question: what do we do with old lithium-ion batteries if we were to get them from Green Cubes to use in our machines?
So we do have customers located in Canada. And the second part of that question, we have the question of recycling or end of life is a sort of complicated one. Believe it or not, for the most part, so we've had batteries in the field for 10 years. For the most part, the batteries, their capacity fades very gradually over time. And so what we define as end of life at, say, 70% of the originally rated capacity is not experienced like that by the end user, right? They see it as just a decrease in performance. And so we've actually, in this industry overall, seen very little in terms of end-of-life batteries. So that part of the battery ecosystem is actually a little bit new. So there isn't a huge established recycling supply chain like there is for lead-acid batteries. We will definitely get there, because now there are a lot of lithium-ion batteries in the field. But for now, those answers are a little bit in the it depends stage. So I would encourage the person who asked that question, if you're working with us or another lithium-ion battery supplier, to ask that question specifically to your use case, so that you can get a more accurate answer than me making some blanket statement.
Okay.
Can I touch on that just a little bit, actually?
Oh, absolutely, John. Go jump in.
So one of the things that that I've learned over the years is, because they use a prismatic cell, as opposed to, I think when a lot of people talk about recyclability, there's a lot of information that goes around in the automotive space where they use a lot of small cylindrical cells that are welded and then dropped into a jar and filled with epoxy so that they don't vibrate and kind of vibrate apart. That's not necessarily the case in the industrial type batteries, because vibration is definitely an issue, but they mitigate that differently than you would with an automobile. So even if in a scenario where you have a cell and you want to get what little you could get back out of that. I mean, an LFP cell really doesn't have any rare earth in it. It's it's lithium and iron, and in most cases it can go in a landfill. It's really that's kind of the reality of it. But if you really wanted to, you could peel it apart like an onion, as opposed to having to figure out a way to incinerate it or get through all that epoxy and everything else around it. So the cells that they do use are very recyclable. But we have also noticed I can't ever give a battery back to them. Our technicians take them. I mean, if we find a battery that we can send back to Green Cubes, it will disappear, because our technicians will take the cells out of it and they'll make electric cars at home or a power wall or whatever. So, I mean, there really is not an end of life. Maybe the battery doesn't fit the form and function of what you wanted it originally to do, but as Robin said, maybe 70% of discharge may not be good enough for its original use case. But the cell is not garbage. It is not. There's nothing wrong with it. It can find another life in something else.
All right. Well, thanks, John. I think looks like we're out of time for any folks that want to get to the final session track for Future of Electrification 2025. That's just starting right about now. But that's the end of our session for today. And thank you to Rob and John for coming on and sharing your expertise, and really appreciate it. Hope the audience, you guys, found it educational and insightful. So we'll call it a day. But if you want to get in touch with Robin or John, their emails are listed on the screen there, or perhaps you can track them down and connect with them on LinkedIn. So with that, wish you all the best for a terrific day, terrific night, whatever time it is. But really appreciate you joining us today, and take care, and we'll see you next time. Thank you, Robin. Thank you, John.
Thank you.
Thanks for having us.